Okay, so today is May 11th. So after back-to-back hard question on the weekend, today we have an easy question. But when I saw the title, I don't necessarily think it's easy. So we have the number 204 count prime. So from the name, you probably already know that we are going to count the prime number in the range, and it's marked as easy, and there are 3,000 upvote and still 700 downvote. So, and the thing that scares me is that there are 8 hints on easy question. So I'm not sure what happened. So I will probably follow the 8 hints one by one to see what happened, and then see what I can learn from this. Like maybe it should be easy, but not that easy questions. Okay. So yeah, let's see what's our 8 hints easy question. So count primes. Count the number of prime number less than a non-negative n. So yeah, it's a range, right? So give you a range, and then tell me how many prime number that we have in here. So yeah, 0 is 0. So the range is from 0 to 5 to the 5 times 10 to the 6. And then yeah, of course 0 and 1 is 0. So without looking at the hint, we probably have 0 and 1 return 0 immediately. So why we have 8 hint in here though? So maybe because the regular way of solving it is not working. But if it's an easy question, why do we got 8 hints? So let's read it one by one. So let's start with its prime function. So to determine if a number is prime, we need to check if it is not divisible by any number less than n. Yes. So the runtime complexity is prime will be O of n, and counting the total prime number will be O of n squared. Can we do better? So yeah. So hint 1 already tells us that we are not going to do the n squared function, right? So the first improvement is that, as we know, the number must be divisible by any number larger than this. We can immediately cut the total iteration in half by dividing that too. Can we still do it? Okay, let's do it one by one. Okay. So the basic of this question is to 2. So I will have a res equals to 0, right? So maybe if n is less than 1, less than 2, return turn 0, right? And then the first hint that we need to have is prime, right? So we have a private is prime. So I give you a number, and then return type is Boolean, definitely. So so originally it said O n square, right? So of course it's like, wait, what is a prime number? Okay, so you need to check if it's not divisible by any number less than n. So intuitively, you will do for int I equals to 2, I smaller or equal to no, less than n. We don't have equal. And I plus plus, and yeah, of course, if n I equals to not equals to 0, not equals to 0, then return false, right? Otherwise return true. So is this what we need originally for the first couple? Line 7. Oh, return is, oh god, for nti equals to 2i small. Do they count n itself? Oh, n should be counted. Equal than n I plus plus. So if like is prime I rest plus and return rest, is that what we need? Right, so 10 0 1, anyway, 10 0 1. So is this what we need? Yeah, so that's hint 1. Hint 2 is that because we know it will be not divisible by n minus 2, so hint 2 only tell you that for this is prime, you only need to go up to this, right? Is that still the case? Less or equal, right? Yeah. And can we still do better? So it probably square root. Calculate for necessary, therefore we only need to consider factors of this, right? Oh, they already give you the code? What the... oh yeah, so you can return in here. So it's probably, yeah, if we do this in here, it's more reasonable, right? I mean, this should be in the count prime or not. Nah, it's the same. Anyways, so they already give you the time complexity n to the 1.5, right? So it's telling you that this you don't need to give all the way. So yeah, so now you change this to I plus less or equal than n, right? Less or equal than n, less or equal than n. So this is hint 3. So basically here they already give you the entire solution. Then we still have 5 more. Ooh, so use space to like, okay, sieve of what? Eratosthenes is one of the most efficient way to find all the prime up to n, but don't let the name scare you. I promise it's concept of surprising simple, really. So we start from the table of n numbers. So all the 2 must be prime. So we mark that off, and then star 3, and then we mark all those off. So this is 2. So now the red is 2. And the green is 3. And so on and so forth, right? Now we look at the next number 4. So now we need to change the entire. So why am I typing the code here? Okay, so we need to change the entire algorithm. So this part still works, right? The is prime is the one that we need to change. No, okay, because I only have one array, so I don't even need is prime, right? So I will probably have so it start from 2. Well, anyway, so I probably will have integer or no Boolean what's that called? SOE, sieve of, okay. So let's call it, where's my code? Where's my code? Let's call it SOE. And the size will be, yeah, SOE. The size will be n, right? I think. Boolean n? N is the one that we want, right? No, we don't need to go up to n. Oh yeah, we need to go up to n. Okay. So we mark, oh no, so I don't want to call it SOE. Let's just call it like not prime or prime. So it starts with, but initially, if you initial a Boolean array, the default value will be false, right? And then we mark that off as true. So it should be not prime, although it's not intuitive, but I don't want to go through the entire array to reset the value to true, so I will just call it not prime and start with false. Everything is not prime. Okay. And then what they said is that you start with 2 and mark everything off. So, and then you go through 3 and you mark every 3's multiples off. So it's like 3 times 2, 3 times 3, 3 times. So we start with 2. And then we go until n. And then we go through the entire array and then mark it true. Okay, so now I do need this. And then, so anti-cur equals to I, and while I is less or equal than n, we go through and then, hold on, I probably need this, and then not prime cur equals to true, right? And then we increment I, right? And then what do we do? So in the end, we count how many is false, right? So do we need to go through that again? Or should I have, for example, int_res equals to, so we have the number from 0 to n, but we already know that 0, 1, 2, wait, how many number do we have? From 1 to n, we have, oh, if I have not prime, then of course not prime 0 is true, and then not prime 1 is true. And then res is, so we have an array of size n plus 1, I think. So n plus 1, we have from 0 to n, right? So we have n plus 1 number. So the rest will be n plus 1, but I minus the previous 2, right? So minus these 2. So it's n minus 1. And then every time, so we mark it as true. So we now check if not this, and we move this to here. And then so if we encounter a new one, then res minus minus, right? And then I always increase so that I don't need to go through the entire array to count it again. So is that what we need right now? I think so. Compile error. Oh, oh, what? I already declare. Okay. Huh? Wait, what? Oh, res return. What are we? What am I doing? Is that? Oh, okay. Wait. I want to count how many of them is false, right? Oh, wait. What did I do wrong? So initially I have this many false, and then every time I encounter something is not already true, I mark it as true, and then I plus itself, right? Hey, what did I do wrong? Why have I 98 of them true? Oh no, hold on. Wait, 2 is prime. 3 is prime, so you need to preset those to prime or not. We know all the, so will not be prime, so we mark off the non-primes. Then we look at the next number 3. But 3 is all the multiple is not, so we mark off as well. Then we took at the next number 4, which is already marked. So we don't need to mark 4, right? So we need to go through 4. And then it is divided by, which means all multiple of 4 must be, so we don't need to go with 4, so we jump to 5. But that's based on I already know 5 is a prime. In fact, we can mark off multiple 5 starting from 5 to 5. Because 2 we already check, 3 already check, and 4 we jump. So we can start from p times p. And then what should we terminate? We terminate on the square root. it's easy to say terminate. Yeah, we terminate on the square root, right? Which is certainly. Do you remember? Oh God, the code is here. I don't want to look at the code. Hold on. So yeah, so we terminate it at the root. And okay, the last hint is only telling us the time complexity is so hard to, I don't understand how they get this number at all. You need to check Wikipedia, I guess. Okay, let's hide hint 8 because hint 8 has the entire code. But one thing I don't get it though, see algorithm step for primes below 1 to 1. Okay, so 1 to 1. So for the number below 1 to 1, you only declare until 120. Why though? Why an easy question is that hard? Are they joking with me? This is an easy question. Generally list from 2 to 30. Yeah. The first number 2 crossed out every second increment. This will all multiple. Yeah, you cross out 2, but that's based on you already know 2 is a prime. The next number in the list is 3, and then you already know, so multiple of. Okay. And then the next number yet not yet crossed out after 3 is 5. Cross out every fifth number list. But I remember we said that we can start from 25, right? Because in here, all the 5 times 2, 5 times 3, 5 times 4 is already marked. So we can directly start from 25. The next number not yet crossed out is 7. The next step will be cross out every 7's multiply. Oh, okay. So let me don't pretend that I'm smart doing this thing. And then not prime. Okay, so when the number started, it's definitely not a prime. So if not prime, I is already true, then continue, right? Because based on hint, hint 6, if it's already marked, we don't need to. Hint 5, 4 is already marked, so we can skip the entire series. And then otherwise, if you didn't skip, then you start from the multiple. So you start from the, so based on hint 6, we start from the square. So we start from I times I, right? And then you go all the way, based on hint 7, you go all the way to the square root, right? Yeah, because hint 7 tell you hint 3, hint 3 tell you square root, right? Oh, so when this is less or equal. This is not I plus. This should be cur. Okay, so you less their square root means that cur times cur is less than or equal than n, and then if not prime is not true. Oh no, I can just directly mark it as true. I don't care, I just mark it as true, right? And then after I mark it as true, oh, okay. Uh, yeah. After we mark it as true, then we increment by I, right? And then yes, and then in the end, let's just traverse through the entire list again. So I have an int res equals to 0, and then for any not boolean, boolean b in what's not prime, if not prime. I know this is not double negative is not a good practice. I will fix it later, but now I don't have time. Res plus plus. This is so hard to read. Not prime. This is not a good practice when you are coding. I heard that from some YouTuber. I forgot, but it's in the LeetCode, the book LeetCode. Hey, if not, no, not B, not B. Oh, still wrong. Okay, I'm not gonna pass this. Hold on. Where did I? Where was? Why I got defeated by this algorithm though? I think I am following this. Okay, I'm gonna look at the hint. So where did I do wrong though? So they still call the is prime. Oh, they use the prime, and then from 2 and I plus plus, if not prime continue. Then you go. Okay. 2 minutes left. Let me do submit the original one that I have. Then let's go back to this one. Come on, 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 come on. Ah, it's already gone. Okay, they don't save that. Oh, I should submit. Okay, 1 minute left. Let me do this. So what did I do originally? Come on. Ah. Ah. So for INTI, oh, oh, too late. Okay, anyway, then let's do that one. Okay, God, this is a easy question. Okay, so what did I do wrong though? I think I follow the. Oh, then where was my code? God. Oh, I also erased my code. Wow, today is a mess. I thought this is an easy question. Okay, so I, like I said, not prime is definitely not a good idea. It confused. I guess I got confused because I used not prime. So is prime is better. And yeah, if we have this, and then of course initially I need to go through the entire array. And is prime wait. So is prime. So I go through the entire array, mark them as true, right? And so now I assume everything is true. So, but I need to mark this 2 as false at least, right? I think. Oh, then I start with 2. Okay, now it's better. And we need this anyway. So let's keep it here. So still the logic is like I traverse through the entire possible number. Oh, yeah, I did it wrong in here. So I traverse through all the possible number, and then this one I should stop with. Oh, no, 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 because I use is not prime. If you check is prime, then yeah. So I times I smaller or equal than n, then I plus plus. Okay, so for this we check if so why they, oh, okay, don't look. So if this number is already false, so it's already not prime, then we continue. Oh, let me close this. I don't want to see this one. So that's based on this, right? That's based on hint 5. It's already not prime. We continue. Otherwise, we start from p squared. So we start from p squared. So no, I don't want to change the I. So we start from this. So we start from this number, and where we should stop. It's still the same, right? So while cur is small or equal than cur times cur is small or equal than n, and then is prime cur equals to false. Then I increment cur by I, right? And that's that. So, and then we increment I and we do it again. And after the for loop, we just traverse through or two. But we have n, so why we don't just use n? So yeah, I can just use n. Okay, and then if is prime, then rest. Yeah, should be the same. Oh god. Boolean n plus 1 t. Huh? 9. Oh. Hey, still okay. Now I need to see what's wrong. What's wrong? What's in my head that keep thinking about the wrong answer? So I start from 2 and then I stop from less than n, because you only have, yeah, I still don't get it. You're checking until n, but your is prime is only do it until n. Loops ending condition instead of square root to avoid repeatedly calling extended. Okay, so this is expensive, I understand. And then if it's not prime, continue. and then j start from I times I, j less than n. Why? Oh yeah, why am I have, yeah, I keep confuse myself. And then you plus n, and then you count. Ah, I missed this one. I keep thinking about this. I don't know. Ah, yes. Okay. So now my only question is that we need to check until n, right? Not skipping n itself. Oh, less than is not less or equal. It's less. It's less. That's why we don't need plus one. We don't count n itself. Oh, we don't count n itself. Yeah. What's the constraint? 10 to the 6. 1, 2, 3, 4, 5. Okay. Okay. So I guess that's today's. So I keep confusing myself. I mean, I keep thinking about we only need to go through the square root. Yeah. But that's this step, not this step. This step you do need to check all the multiply by that number, right? So I somehow keep putting this logic in here. I don't know why. And then the other thing is I shouldn't confuse myself's logic by declaring an array called is not prime, because I will have to do a double negative in here. So not prime, and that will confuse, like in a production environment, this will confuse other people who maintain your code. So yeah. So, and I probably can, so this part I can remove. So yeah. So this is today's question. So, and then the time complexity, I give up. I give up. I will not be able to analyze this. Oh, that's, what's that? Is that a proof? Okay, I don't understand at all. The part, I don't know if we encounter anything, what encounter this problem during the interview, should we use this? The problem is I can't analyze the time complexity though. I totally don't understand. I can force myself memorize this, but I would not be able to know how. they got this number. So yeah, I don't know. And the thing is, I remember there is a easier way to do the prime checking. So check if prime. Because I remember I used to check Wikipedia, and there is a not too hard way, but I can't find it now. Yeah, but it's definitely not this. Oh, this one. Yeah, they already provide the code in here. So I used to use this simple method. So it's the 6k plus I method. So yeah, I didn't really use this. I didn't even notice that they mentioned this in this Wikipedia page. So that's what I used before, because I think we only need to, oh, they have JavaScript code. Yeah, but in the past this is what I used. So they have an explanation on why we only need to check uh, where's the magic number 6. Yeah, so you only need to check 6k plus or minus 1. So yeah, that's what I used to use, but I never used this. I guess this, I don't even know how to pronounce it. It's a way of trading the space for the time. Yeah, but this is easier to analyze the time complexity though. So okay, I failed again today on the easy question. So, and I guess that's it for today. And hopefully tomorrow I can do better. So yeah, thank you for watching for today's daily challenge. I will see you tomorrow. Thank you. Bye bye.